Welcome back everybody. I'm going to give those cells a rest. I'm starting a new cell design using some plastic cut out electrode shapes. I have two zinc ones for the negative side. I just coated those with the conductive ink. And first I put some copper tape around there for extra strength, and then I dipped it into the conductive ink and then allowed it to dry and coated it with zinc both sides. We'll have a close-up look at these under the microscope. So that's the side what's going to face the positive plate, and same with that one. I have some brass bolts which allow that, so from that point there down to the bottom is 1 ohm. And for the positive side I did the same. I coated it in ink and then I nickel plated it with the nickel tabs you buy for lithium ion batteries. I got some in nickel ammonia nickel sulfate plating right now. I first plated it straight under the carbon, but it was looking all good, and then once it sort of dried it sheared the carbon, so there was the ink on this side and plus the ink left onto the plastic, so it sheared off. And I was going to grind it up, and I'm probably going to, after this is nickel plated, so I copper plated it first now, and hopefully the nickel, this has been in there for about 5 minutes. And we got a layer of nickel already. You can see the copper plating down there. I took the copper plating right up. That measured from that top bolt all the way to the bottom 0.1 ohm. So that was like pretty impressive. And I used this as my anode. And it didn't really use a lot of copper. So I'll plate both sides of that, and then I'll use some nickel hydroxide. And this is that nickel hydroxide I was soaking those things in, so there's bits of carbon also fell off. So I'll mix both of those up, use the ink, paint over the nickel, and sprinkle this stuff on top, and then sort of lightly press it. And that will be the positive plate. For the zinc side, I used that much of one of those plates and a little bit of this other one, so not too much. Under the microscope, see how it looks like it's pitted. They look like little trees. Let's see if we can sort of do a crude look through this thing. So if it doesn't sort of work out that well, I might try copper plating these ones as well. That should increase its conductivity and may also perform better, not knowing yet. So I'll let that go for about an hour. I'm running at 3 volts, 600 milliamps, and I've just got 3 strips of this stuff. That's nickel, by the way. Alright, we'll get back. 3 hours later. Okay, we have a successful plating of nickel on both sides. I did 1.5 hours on each side. Those marks you see there are just the grinding marks I put in the carbon to increase the into the plastic before coating it with the FWG conductive ink, just to give it extra gripping power, because this plastic was a serving tray and they're really shiny. It's a real hard plastic. It cuts best with a grinder actually. It doesn't melt, it just powders off. so you've got to wear a mask. So success with the copper plating, and then also nickel plating on top of the copper, which helped greatly. And what's left of our nickel, there's not a lot, but that did 2 plates really. The first one failed, as I showed you those flakes, which I might crush them up and also stick them in as nickel flakes into the mix. So there's 5 grams left in that batch, which is a pure batch. Normally a pure batch gives you 10 grams of nickel hydroxide. This was the batch I made, and that probably would have had 10 grams as well, plus the bits of the round carbon cylinders what broke off as I was submerging them. So it's probably, I don't know, I'll weigh that up and then we'll get a measurement of how much carbon could be in there. So I'll give that a rinse. There's some stuff at the bottom of the ammonia nickel sulfate, which is probably sulfate maybe, I'm not sure, or ammonia. I used copper sulfate for the copper plating and a piece of copper pipe. And for the zinc, I just used those zincs here. So zinc sulfate sort of doesn't really plate, it causes dendrite. Well, it sort of does plate where I pressed down there and checked it all out. But that should give us surface area, but it may need to be copper plated first. Also, these ones were coated like 6 times. You don't have to coat them 6 times. This one I only coated 2 times, 2 dips into the conductive ink, and then dried them in the sun, which was 30 degrees, 33 degrees outside. We'll look at these under the scope and see what it looks like for the surface area. I would have liked some bubbles to increase the surface area on this plate. So the plate's going to be 2 of these cells, one either side of this one, and that stuff there with the conductive ink. I'll paint conductive ink and sprinkle the stuff over it on both sides and see how that goes. And for the binder, I'll wrap the microporous overalls around the positive plate completely to keep the nickel oxyhydroxide in there, and hopefully it won't turn the solution black. So that's the plan. The nickel must be shrinking. 1 hour after drying, look. And that's what it did just being plated. This side's sort of okay. Maybe too thick with the nickel. Okay, so I thought I had to chuck away my ammonia and nickel sulfate because that would have been contaminated with these strips. A good test is if you buy your nickel, set up some vinegar in a dish or something and do some electrolysis for about a couple of seconds, all it takes. Should look like this. That's the negative side where it starts plating, and the positive side will be clean and there won't be any of that black crap floating around. This is one which isn't nickel, and you can see the difference clearly. There's probably a bit of contamination on there. I'll wipe that clean from being in this solution for an hour with these things. These things are definitely not nickel. It should be plating that colour really, or somewhat that colour without this contamination. So buy your nickel, test it. Bad, report to the seller ASAP. Just finished coating the electrode with copper. Every time I flip it over it turns black on one side like that. I think it's covered pretty well. It's had an extra couple of hours in plating. The nickel acetate's ready. It took 6 hours at 4 volts and about 500 milliamps to get this stuff done. I think there's some zinc floating around nickel floating around the bottom. So I'm going to attempt to nickel plate this now. There's no peeling with the copper. I've given it a wash underwater a couple of times actually and scrubbed it with a brush. So it should be good. It's completely sealed. Okay, fingers crossed this nickel acetate works. A layer of nickels just instantly appeared over it. It's running 3 volts at 450 milliamps. Okay, the cell's been out of the nickel acetate for about 5 minutes. It had an hour each side. That side's got streaks for some reason. They're like little layers or little trees, dendrites of nickel. So an hour, probably not for plating but for a battery cell, it's okay. Because we want those little areas for surface areas, I imagine. So it's got to last an hour before it peels off, hopefully, fingers crossed. Now the resistance from the brass lug to here is it's on the 200 range, 0.5 ohms, which ain't too bad, pretty good, that should do. I'm going to use this mesh to sieve the nickel oxyhydroxide, should say nickel hydroxide, and the nickel hydroxide in little bits of carbon as well. I think there's 10 grams there, 5 there. So I'll just coat it with a brush and the conductive ink and sprinkle some of that over both sides of that plate. That's tomorrow's job. I'll allow it to dry though, because there's a spot on this side which is sort of freaking me out right there, but it looks like a trace line of where the plating was going and not a crack. Same with there. It's probably the least resistance path. There must have been lines of really low resistance to build up like that. It was forming those lines in the copper, so I left some copper up there. And the zinky ones, they're probably overkill with plating, but that's alright. I figured if we saturate the potassium hydroxide, the zinc will have to stay here in place pretty much because it's got nowhere really to go. Okay, I'll get back in an hour. Okay, weighing up the active material, the nickel hydroxide mixed with some carbon which fell off of the dipping process. So we have 5.8 on one side and 5.79 grams on the other side. I'm getting ready to paint one side and sprinkle this stuff. It's going to be put on this screen and sprinkled over the conductive ink I'm going to coat over this. So that's around about an hour and 45 minutes, and we're looking good. So we haven't broken. It was only breaking because it was maybe chrome or something and not nickel, and it may also be the ammonia in that ammonia nickel sulfate. So at a later date I'll do another small little batch and test to see if it will actually plate over. But for now I've got a working electrode. Okay, so I gave it a layer of ink both sides, sprinkled the stuff on and pressed it. A lot of it will come off, but that's alright, we can keep it. But hopefully a fair bit of it will stick. I'm going to squash it or put a bit of weight on it to keep it flat overnight, and by tomorrow it should be good to go. Right, it's the next day. The ink's dried. There's 5 grams on both sides. The time I shook all the stuff off, that's what came off. That's 7.61 grams of the nickel hydroxide and carbon mix. So there's around about 5 grams on both sides of that. I brushed it off with a brush. So that stuff stuck pretty well. I could probably keep brushing, but I'm going to bag that up in the micro porous overalls. I'm going to completely seal it, so I'll wrap it around and fold it and put a rubber band down here and a rubber band up here. I had this little Tupperware container. I'm going to put a little bit of potassium hydroxide in there to see if it reacts to the plastic or not. Because the glass ones, they're starting to frost, so I'm not sure how long they'll last, and I don't have a glass container that big. Also might get a little spill thing to sit this in, so it doesn't spill if it does eat through this. It should be alright. I have a larger one, but don't need that one. I have a good little seal, so the battery actually works. I might melt some holes through here to stick the electrodes and glue them in, but we don't know if it's going to work yet, so I won't wreck my dish. I'm going to try to put 10 grams of zinc sulfate into the potassium hydroxide. It takes 700 mils. At 6 mol is 235 grams I need. And slowly I'm running out of 1 kilo already. Yeah, you use that stuff pretty quickly. Alright, so I'll mix everything up and get ready. Positive cells totally wrapped now in micro porous overalls. That should keep everything in there. 2 negative ones get bolted together like this, and this one gets slid in between there. Ten grams of nickel oxide dissolved into 700 mils, quite easy. That's a 6 mol solution of potassium hydroxide. There's a smidgen down there. I'll keep stirring for a while, but that's getting ready. Testing the container out. It's been in there for about 5 minutes. It's only a drop. No discoloration. I'll leave it for an hour. I have a backup container just in case. Should be all good though, presuming. I just filled the container. It took all 700 mils. I'm thinking I probably should have coated the negative ones in copper too. Right down there, see that little white patch? I think I have a breakage. Could be the plastic too, doesn't want to stick the stuff to. So we're out of charge it. It's 1 volt. 1.1 holding there, so I'll leave it. It's probably got to soak in for a while. Not sure how porous that coveralls are. But I know that doesn't dissolve because I used a piece in one of those round cells and it seems to be okay. It got a higher voltage, so we'll do a quick little load test and then we'll just sit here and monitor it. So it's 100 milliamps. Now it drops straight off there, so we'll leave it there, sit around for a while, about an hour. Some of the zinc fell off there, see that? That's excessive. And we've got some bubbling going on. So now I wish I actually coated those negative ones in copper. Probably get a better performance. That's okay, it's only a trial cell. But that's the sort of style I'm going for. 2 plate, 1 plate. Okay, it's been an hour just sitting around. It's probably nearly dropped 0.2 of a volt in an hour. It's about to charge. So I'm going to try a charge of 2 volts first up. Clearing the curve. And connecting the charge. Okay, it's only like 182 milliamps. Well, we'll leave it at that and see what happens. Right, it's been on charge for 3 hours and 24 minutes, but I think it's peeling off on the negative side. I should have coated it with copper, but we'll see how it goes. So I'll disconnect the charge. So it may not run very well. Some design issues. Okay, got it connected. Starting 100 milliamp test. Not sure if it will even do 100. Alright, but not very good. It's dropping heaps. Electrolyte's sort of changing colour. It's going a bit grey. Might change that to 50 milliamps for a while. So I can deplete some of the zinc and see what's going on. Ah, whoops. When I do that, I wanted to continue. Anyway, here we go again. Really does look like it's splitting off of there. See that little dark line crack? And that corner's getting bigger. It's peeling away. Doesn't like that plastic. I'll find another plastic, I reckon. That was a serving tray, so I'm not sure about that one. Back to the drawing board. Well, not a very good run. 20 milliamp hours, 18 milliamp hours in 21 minutes. So I'll charge it up again. Might try 2.5 volts. So I'm not sure what the front face of that electrode will look like, but that down there looks like it's detaching. See that? This one's holding up better by the looks of it, but the amount of power for something like large, yeah, it should work a bit better. I think it would probably be beneficial to have those copper plated, the negative cells. Bounce back's 1.4 though, but no energy. Alright, I'll start another charge and get back. This is how the cell should be running. 1.5 volts, 500 milliamps, but I have a pieces of zinc instead of the electrode. It's collapsing there big time. So it's had 3 charges, but it's getting worse. So that's without a charge, that's just having that zinc plate dropped in there. And the positive just floating around. But the zinc plate will dissolve away eventually and it will recharge. Doing 900 milliamps, quite easy. Alright, so we've got to try to reproduce that. So I reckon I might copper coat some different plastic. Well, the ink is sort of bubbling. The zinc has all dissolved off of it, as you can see. So I'll clean these down. I'll use the same ones because I have a little theory. If I'm gonna clean them down, coat them once, and then nickel plate them straight over the ink. Should work because I have the real nickel solution now instead of something whatever that whatever this stuff is not nickel. Probably maybe a little nickel coating with stainless. Seems to get tighter the bend when you bend it. Seems to work harden, so that suggests stainless to me. And I'm thinking if the stuff dissolves, the nickel plate will be right around anyway. It'll be like a little shell. Later after that test, after I nickel plate it, I'm going to nickel plate it, coat it again with ink, and plate it again, and then see if I can dissolve the ink out, and that way we can have a little micro lattice of nickel right around. I was going to do copper, but nickel's corrosive resistance and it shouldn't matter if it's both sides nickel. At the moment I've got 2 of those zinc plates. I'm going to give it a charge up for a while and see what the potential of the cell is. I think after yesterday's little run, it should, with 1 plate, the double plate should work pretty good. Cell's been on charge for 3 hours now, 3 hours and 5 minutes with 2 zinc plates either side. Going to try 2 amps, so disconnecting the charge. And cell voltage looks okay for now, but it will drop right down a fair bit. But it's normally a good sign when it's about 2 as it drops. Okay, we're 1.9 and starting 2 amp test. Oh, Oh no, it can't do 2 amps. Look, oh yes, there it is. So this will be the first time I've done 2 amps on this data logger. See how long it goes for. So that's just running off of the nickel plated cell with some nickel oxyhydroxide coated onto it. It's in its little sheath or separator bag, which having 2 amps go through it should mean the microporous overalls are probably working out. We have a bit of a hiccup here. We went up in voltage. We got loose wires maybe. Oh, we're dropping really fast now. Might back that off and give it a reasonable test. Maybe 1 amp. 2 amps a bit strenuous. There we go. Does 1 amp, pretty good. I still thought there would be a bit more power in the cell. I'll move the plate closer, one side. Well, it doesn't seem to make much. Oh, a little bit. Nah, no difference. So they can be spaced out pretty well. Alright, so the object of this is to reproduce this run with the plastic electrodes. I just backed it off then to 500 milliamps. I think it was actually running better last night. So that center cell could be degrading. It only had 1 plate on it last night. I wonder if I'll pull one out. Alright, no difference. I have a plate completely out of the liquid. So I'll slowly stick that plate back in. So we got a slight rise in voltage, and that's it. I'm pretty sure it was doing 1.2 last night on 900 milliamps. Okay, we got 16 minutes out of that cell. I think it was, I checked the video last night of that little run with 500 milliamps and then 900, and the voltage was much stronger and holding. So now I think the binder on the positive sides has dropped off, or it's loosening. I've got another hour before I can nickel plate the other electrodes, so I'll give it another charge for an hour and see what happens. But back to that issue of binder. Cell's been uncharged for 1 hour, starting 500 milliamps. "25 minutes for that run, 210 milliamp hours, 210 milliwatt hours. Looks all puffy down there, but that could be electrolyte. Does look a bit thicker, so not sure on the state of that one yet. But that can just sit around until later. Won't touch that until the other plates are ready. First copper coated electrode ready. Oh, nearly dropped it. Yeah, drop it and break it. That would be funny. That's the seam line. of the copper tape. I took it right up this time. That was one of the failing parts here. It would wear it through here, there would be no conductivity. So 2 hours and 40 minutes thereabouts. That's some sort of discoloration forming, I think. And they're not little channels, they're little ridges. This side seems to be slightly pitted. I'm not sure if I need more time. Again, that's where the copper tape seam line is. I think it's bonded, and we'll have a better conduct now and contact point. I first started off here in the liquid, and then once it starts coating slightly, I lower it into the rest of it. Okay, waiting on the other ones, just being put in. I did try to nickel coat that one, which I had it all submerged, but it started nickel coating under the copper tape, or under the conductive ink, and flaked the ink off. So I had to repaint that one and get that one ready before this was done. So they take 2 hours and 40 minutes. I don't know what that is. It's a blemish on the surface, or is it in? The edges are completely done, so it's a self-contained shell. Copper coated plastic plate. It's oxidized, as you can see. I checked the spots from that point up here to anywhere on the surface, even on the dark spots, is 0.5 ohms on this one. Same with the other one. I've decided to go for a coating of nickel on the negative plates because copper does react with the potassium hydroxide, so we probably want to eliminate that actually before we start putting copper ions into our potassium hydroxide. I peeked down there last night and pried that apart, and it seems like the binder's still attached up the top, so I'd imagine it's still intact. It's mainly the conductive ink doesn't really attach itself to this type of plastic, whatever it is. I'll go show you it. So it's one of these serving trays. It's a brittle plastic, very hard and snaps easy. So probably not the best choice, but it was free. that shouldn't be a motive for choosing plastics, but it was in my case. So 2 hours each side seems to be a good amount of coating. For an electrode, that is. That increases its surface area because it gives those little bumps and things. So I've just put that in there. And we're slowly getting some around the outside. taken it right up. That should protect it. Covered everything, including the bolt hole. That's just a bit of copper tape I bent around. Well, I had the hole drilled first and put the tape around, and then using the biro just punched a hole both ends and folded it in. Worked out quite well. That one's a bit sloppy. That was my first attempt. The other one's pretty neat. That shouldn't matter anyway. We're only worried about the surface here. Ah, yeah, I just got my new copper sulfate hexahydrate. And the other one was ammonia and nickel sulfate. So this one doesn't say anything about ammonia being in it. So I'm going to give this one a try. The negative electrodes plated with nickel, 1 hour each side. This one turned out not too bad looking, but it's just come out of the electrolyte. That one's been sitting for 2 hours outside. So got some of this, probably some copper coming through from the plating process and being in the electrolyte, I think. So I'll stick their little bolts in. I won't connect them, so I can pull out one and I'll connect them with a lead. So I'll set that up and get ready to put it in the cell and charge it. The cell now has two nickel coated negative electrodes, and they haven't been plated yet out with zinc, meaning there's no charge yet. We're sitting at 0.7 and we're going to charge it at 2 volts, starting the monitoring for about 2 hours just to check. Okay, it's taking in 3 amps at 2 volts. That's pretty good, I think. It's making a bit of gas. Maybe I should back it off. That's really gassy for some reason. It's only at 1.8. Maybe nickel's a catalyst for making hydrogen. Well, I'll give it a half hour at that and see what happens. The cell doesn't look like it's plating with zinc. Maybe there's not enough zinc in solution, but I thought there would have been. It's been on charge for 2 hours and 28 minutes. The voltage is slowly going up still and the amperage is going down, but I can't notice any plating. The zinc plates sort of have a bit of plating on there, so maybe it's all taken out. Okay, so far the cell's been uncharged for 4 hours and 34 minutes. It's been steadily going down in amperage and voltage is still raising. I guess it's going to raise to 2.04. But I'll start a test now just to see what it does, and these where it dropped off is where I've taken off the charge and checked the voltage. It drops down to 1.6 pretty straight away, so I'll just disconnect. Okay, so it's at 1.6, we've got a 100 milliamp load. I haven't seen any plating on the negative side yet of zinc, but could need a lot longer charge. I put some extra grams of zinc oxide down the sides and it just frizzled up, so maybe the electrolyte needs more zinc in it. It might be plating and stripping it off at the same time. So I'll see how long it goes. I'll charge it up longer tomorrow when I'm at work. The results, 18-minute runtime, so it's not looking good. I'll try adding some more zinc oxide and charge it up at another date. This is the contaminated nickel sulfate I used to electroplate first up. I decided to turn it into nickel hydroxide, but look, see that brown stuff? That's probably like chromium oxide or something, which is very toxic. It absorbs through your skin. So I'm going to try to suck that layer off and store it in the container and let it evaporate and then dispose of it. I'm going to glove up for that because it goes through your skin if it is chromium oxide. Cell's been on charge for 2 hours and 35 minutes this morning. I plated one of the cells in some zinc sulfate and gave it a layer of zinc. As soon as I put it in here, it dissolved it off. So the concentration of zinc needs to be lifted. So I just dropped that plate in there. That plate, actually, it's a zinc plate. It's not connected. It's just hanging out there with a rusty old end. Improves the cell by heaps. I'm just putting it in there to get some more zinc in the cell for now. I didn't have time to mix stuff up while I went to work this morning. See, it's holding its 1.9 volts with the thing disconnected. Charger, that is. Disconnecting the other end of the data logger now. It's a bit of a pain, have to swap leads over. I should make a little switchboard. Okay, we're at 1.8 with that little zinc plate in there. If I take that out, it will drop down to 1.6. So we're 100 milliamps again. So that zinc plate's only just resting on that little negative electrode there. And look at it. That's just crazy. So if I pull this one out, I chucked some zinc powder in there, that's what just stuck to that plate there. I'm going to pull the plates out and stir that solution all day and put some more zinc in it. Because it's not plating. It won't plate to the, there's no, I don't know what's going on there. It does plate in zinc sulfate. It's only a 6 mole concentration. It only had like 230 grams of potassium hydroxide in it. I think I put 90 grams in the little ones. But I saturated them with zinc powder and some zinc oxide, so we're probably not zincate yet out of total. Because the amount of bubbles that came off my plate as soon as I put it into the electrolyte was just frizzled the zinc layer off in about a couple of seconds. Still bubbling crazily, look at it on the discharge. those streams are coming from the negative side over to that side, the middle one, which is the positive. Okay, that was 1 hour and 38 minutes with that zinc in there. I pulled the zinc out and it just dropped, you watch. I'll pull it out of there. Now the voltage is still high. I thought that would have dropped. So it's still reacting. You can sort of see all those bubbles coming off the nickel plate. So I'm going to put more nickel in, zinc in there. So I'm stir it up and give it another charge and keep charging it with that plate and see what happens. For now. Alright, I just mixed in another 20 grams of zinc oxide. You can sort of see some of it there. And it's on charge now. It's doing 1 amp, 1.9 volts, set on. I think it still needs a lot more zinc oxide in it because it consumed that pretty quickly. And I reckon it's plating and dissolving off. That's what we're seeing there. That was the plate what was in there. So it's chewed through it a fair bit. So it's dissolving. So it's got a total of 50 grams zinc oxide, 1 gram of zinc powder, and some of that. And it's still bubbling too much. The other cell never used, the round cells was saturated with zinc before I did anything with it. So if that keeps bubbling like that, it's not working. Okay, I turned up the voltage about 20 minutes ago to 2.5. Now I'm getting some zinc plating. Interesting. Maybe, and it's not bubbling as much. See, there's no squirting out of that white stuff, it's accumulating now. So that's quite interesting. Wonder why I had to increase the voltage on it. It's pumping in 1.3 amps now. So I'll give it another, maybe an hour. I'll go 2.5 hours and see what happens. There's zinc sulfate accumulating down there though. I mean zinc oxide. So it needs a good stirring. Cell's been on charge for 2 hours and 6 minutes, and that's an hour at 2.5 volts. I increased it, and we have plating of zinc, not very much, but it will do for now. I'm going to run out of time. We've got about an hour left. I have to go. So I'll disconnect the charge, connect the other end of the data logger. This time we don't have the zinc plate in there, and we're at 2. Oh, where's our voltage? Hey. Oh, we're shorting out. Damn it. The cell flipped over and landed on it. Yeah, landed on the positive side over here. So that killed the cell pretty quickly. Oh, we're still shorting out. Alright, we're at 1.2 volts. That'll do for now. Starting. So the electrolyte's not so violent looking now. Oh, except for over there it is. Okay, no, just as violent. Those two plates touched, it fell over. Okay, it looks like the battery's actually coming online now. 45 minutes run time. I gotta go out now and I won't be back until later, so it's not worth keeping it running. But tomorrow when I'm at work I can charge it up longer. And the reaction's sort of not as strong now. But some of the zinc's still dissolving, so it will get better. Hopefully, should. Can't see it not working. Had me worried for a bit. Didn't think the nickel was going to work on the negative side. Still may not, but worth checking. So we'll get back tomorrow and see what it is like. We might as well see what voltage bounce back is. There you go, pretty average, didn't quite get to 1 volt. Probably will creep up, but... So at 0.9 now, I'll check it tomorrow morning and see where it sits. Alright, back from work, 6 hours on charge. I put it on before I left work this morning. It's been doing about 1.2 amps for a while. Set on 2.5 volts, it's only 2.4 up there. It's slightly increasing still, so maybe we could take it longer, but I gotta go out in about an hour or half hour. There's zinc on there, so it's plating out now. Whoops, I won't lift that side. Oh no, because I just disturbed the cell, I think. I'll keep it there. It's a bit still violent looking in there, as you can see where I moved it. But other than that, at 2.5 volt, it's looking good. So I'll disconnect charge now. And we're at 2, dropping fast. That's good though. It's when it's under 2 at the disconnection here, it's not looking good. Okay. Connecting the leads. Okay, we're still at 2 volts, that's looking impressive, but will it run, and how long will it run for? Hoping it will beat the round cells, so it has to get to 300 milliamp hours. Okay, 100 milliamp load, we're actually looking pretty good, we're 1.9, wow. Alright, fingers crossed. So it's had 50 grams of nickel oxide in there, 1 gram of nickel powder, and a little bit of that sheet, but some of that was taken off on the other run where we did some nickel plating, zinc plating, so probably looking about 52 grams maybe of zinc into that cell. The plates are spaced pretty far apart. We only probably need like 10 mil or a finger distance between each cell. They would need some sort of spacer to hold them in place. That will eliminate dendrites touching the positive, because after 6 hours we've only got like 6 millimeters of growth hanging off of the side, and if you don't stick too much zinc in there you're not going to get any further than 6 millimeters. Okay, I think I have to work on the positive side of the cell. See, major drop there for some reason, and then it's flattening out. It's still at 0.9 volts. Results of the test, 2 hours and 28, so not quite 300 milliamp hours. Only 247. Not sure why it dropped right off really quickly. because it's the state of the zinc plates, they've still got zinc on them. It's most probably that, see it's like puffy down there. I'm not sure if that's liquid or the binders come loose. So, yet to see. Yeah, it's a 0.9 volts rebound, so a little bit short of the 300 milliamp hours. But we'll see how it goes with another test or so. And then I'll try to make a new positive cell, I reckon. This time I'll use cellulose acetate as the binder. And maybe a bit of luck. Okay, testing out a 5 hour and 41 minute charge today. I put it on 2.3 volts and we're doing about 727 milliamps. Disconnecting charge. Okay, we should have a voltage. Okay, voltage is still pretty good. Wondering if it drops again rapidly. Most of the zinc was still on the cell this morning, so I don't think that's the issue. I think it's the positive plate. I'm not sure what the state of the binder is on the cell itself. Alright, let that run, get back later. Well, the cell seems to be a bit inconsistent, only 1 hour and 30 minutes today. So either it's a lower voltage charge, needs a higher one, I'm not sure. I think further testing is required. I can hear it bubbling. Yeah, it has zinc still on the plates. Probably should have put a light on, but see the different colour there? That's the zinc line. I think I'll either give it a test tomorrow or post the video, because I'm working on another positive plate, but that won't be ready for a week. I gotta make some nickel hydroxide and stuff, so that's a week away because I let it settle and then drain it, wash it, and do the same 3 times. Back with a 4 hour charge today. I have the cells at a closer distance now. Hopefully the voltage drop after a couple of seconds or whatever it is won't be as high. Starting 100 milliamp test. I'm working on the new plate now. First it gets copper coated. I got another hour on this side to get the middle of the cell. I'm thinking about using some of this air conditioner filter carbon. You can sort of see through it. It's not unconductive, so I'll paint it with the ink. Then I'll copper coat it and zinc coat it. I mean nickel coat it. That should give us a bit more surface area. I would have liked some more meshier stuff like this copper mesh maybe. This mesh comes from is a something to do with steel, goes in the chimney or something. Okay, something's causing a major voltage drop in the cell. some sort of resistance, or maybe the active material on the positive side ain't enough. As it goes pretty good, about 2 minutes, and then bloop. I'm pretty sure I looked down in the positive cell and poked around with the tweezers, and the stuff is peeling off, so that's probably one of the reasons. Okay, cell fell over, only 38 minutes. I know the reason. I did an autopsy on the thing. That's the plate. Either I didn't coat it thick enough, but there was two issues. The binder, the stuff was down at the bottom, so it washed off, and I'm not sure if I ripped it or there was a slight rip through the copper and the nickel on the cell. This one, see how it looks a bit fat there, like an air bubble behind it. So the ink's lifting off but holding together. So this is obsolete, I guess, because the ink doesn't stick to that plastic very well. So unless there's some sort of other factor when you're adding a charge through the cell which is making it come off, not sure. Seems to plate pretty good. Let's put it in potassium hydroxide. This plate's holding up well, there's no coming off. Just that side, and it's on the back side which doesn't plate. I'll go outside and show you the stuff that fell off. It stays pretty much intact. That's the back side of it. So it's plated around this way. The sides and the corners are alright. That was the state of the stuff. I found it. It was just floating around in the separator. So two errors I know of. Yeah, it's left those weird grinding marks in that ink. See it? So maybe the plastic is peeling off. Alright, hope you enjoy this video. I'll remake when I find some decent plastics, and I'll get back to you. Thanks for watching. Okay, I was testing this stuff. That was the ammonium nickel chloride that I put those non-nickel plates in because they said it was nickel, but it wasn't. So I filtered out the brown stuff mainly. But it's still, it's not looking like a great nickel hydroxide, so I might dump it. But what I was doing, I grabbed a bit of that after it's been washed like 3 times. I filled that bucket up with water. I only used tap water this time because I didn't want to waste it because it was contaminated. Nothing seemed to be happening. I've got it right down the back here. I stirred it for an hour. I put some bleach in there and I came out and it was like, wow, it's turned black. So that might be nickel oxyhydroxide, but contaminated version of it. So I'll sometime when I get some time, I'll make up a batch of good nickel hydroxide, wash it, filter it out sort of. I siphon it out and let it stay in some solution, and then I'll put it out here and stir it up with some bleach. I definitely made sure I washed out the ammonia part of the ammonia nickel hydroxide, ammonia nickel sulfate, because bleach and ammonia will kill you. So you can't take any risks, so make sure you wash it. Or actually get a nickel sulfate or another nickel without any ammonia would be better. But it's 3 times that bucket size. That's over 3 litres worth, and it was only, what was the batch size? I think it was only like 500. It was 500 mils and 80 grams of the nickel hydroxide I wasted for plating. Well, not nickel hydroxide, but nickel sulfate. I got my little pads painted with the ink. I decided to make 4 of them, but I have to find some plastic. I have perspex, but I don't know how that will work. I'll hunt around for some other plastics. Oh, and I also only put 6 mils of bleach in there. I squirted 2 mil at a time, and I did it 3 times and then ran off quickly because I didn't know what was going on. And it's not fuming or anything, so looks safe. I'll leave it there for the rest of the day. I just noticed that it's dropping out of solution pretty quickly. You can definitely see the water line and then the black line. It's still bubbling, so I can see little bubbles, so it's still reacting. See the bubbles on the top? Since I was already halfway done with plating that one with copper, I had 2 hours on each side, so it's a thicker coat than those ones. They're only an hour each side. So I'll do 3 hours each side with nickel, because that nickel's done 4 plates, and look, it's still intact, so I'm not really plating very thickly. So maybe a thicker coat will hold that cell intact better. So I've just put it in there. It's only at 200 milliamps. So I'm pretty wrapped with the nickel oxyhydroxide, I hope.